we officially only have 2 more lessons left in this whole semester, and both of them play off of today's topic, which is graphing linear inequalities. Now, we've kind of graphed inequalities before. Remember from like unit 3 we graphed stuff like x is greater than 4. That's an inequality, just doesn't have an equal sign, has a greater than, less than. But we graphed them on the number line. So if you guys remember this, we looked at that part of the number line and we said, okay, this would be an open circle, and I would shade that, all the numbers bigger than 4, that's what I want to show. I would shade that to the right. So it's kind of like this example, except instead of graphing them on the number line, we're going to graph them on the coordinate plane. So the x and y axis. But it kind of follows along with that, so that's good to recall. Now, this lesson may seem a bit out of place because we've been talking about systems. So this is kind of like an odd lesson out, but it's necessary to learn today's skills so that way you can graph systems of inequalities next time, which is the very last unit or lesson of the whole semester. So today we're just going to learn how to graph one linear inequality, but next time we're going to graph systems of linear inequalities, 2 of them. So it actually does fit in with this unit. This specific lesson on its own, though, might just seem a bit off. But before we get started, please remember that when you graph something in algebra, like what are you doing when you graph? Well, you're providing someone with a visual for where the solutions are. Okay, that's what a graph is. That's what this graph showed right here. X is greater than 4. X can be any number bigger than 4, so I'm going to show that on the number line by shading. Okay, when you graph a linear equation that has an equal sign or just a line, you're showing someone where all the answers are. So let's just like review how to graph a line. Done a lot with this semester. Steps are over here. Easiest way to graph is to be in mx plus b. So we know that m is the slope, b is the y-intercept, and we just plot the points from that. So I start with the b value, which is -1. That's where I cross the y-axis, and then I count my slope. So I would go up 3 over 1. Once I've got some points plotted, I can connect the points, don't forget to do that part, with a line to show the solutions. Okay, so there's my line. And again, realize that all the ordered pairs on the line are answers to this equation. So that's what a graph does. It shows where the answers are. So here's what I mean by that. Like any ordered pair, and it doesn't technically have to be nice ordered pairs, like any ordered pair on this line. I can plug those x and y's in and it should make this equation true. So let's just do like a nice one here. This is the ordered pair 1, 2. So 1's the x, 2's the y. I can plug those in to my equation right here. So y is 2, 3 times the x value, which is 1, minus 1, and it should make it work. And what I mean by work is it's the same number on both sides. And yeah, 3 times 1 is 1, minus 3, 2 equals 2. That worked. Okay, so any ordered pair on that line makes the equation work. Now, today, it's very similar to graphing a linear equation, but instead we're going to be graphing a linear inequality. It's still a line, that's what linear means. I'm just not looking at an equal sign anymore. I'm going to be looking at like greater than, less than, or greater than, or less than, or equal to. You still start the same way though. You still want to be in mx plus b, and you still plot the points like we did up here. So the y-intercept is still -1, and I would still count my slope up 3, right 1. So plotting the points does not change. These 2 new things are what we have to learn for today. So this guy and this guy. And guys, it's really similar to what we did on the number line right here. Remember, we had to figure out, is it open circle, closed circle, and which way do I shade? So similar here, except instead of what kind of circle is it, you have to figure out what kind of line it is. You've got two options. It's either a dashed line, something like that, or it's a solid line. Solid line's easiest to pick out. If you have the solid line underneath the sign, then it's a solid line on the graph. So the or equal to signs, those two have solid lines on the graph. If it doesn't have the or equal to, so it's just less than or greater than, those are dashed lines on the graph. My example right here, it has that or equal to, or that solid line underneath the symbol, so I'm going to connect my points with a solid line. We are so used to drawing a solid line that you need to be careful and think close about that part before you just rush to draw a solid line. Okay, and then you have to think about where to shade. And I'll explain like what the differences are once we've got the full picture. But you shade, just like we shaded left or right, you're gonna either shade above or below the line. So the symbols that would tell you to shade above the line are greater thans. So if it's greater than or equal to. Okay, so those symbols, the greater thans, shade above, and the less thans, shade below. So on this one, this is a greater than, Y is bigger, the mouth open towards what's bigger. So this is greater than, so I want to shade above. And you know, a lot of times you can just go like this, pull your pencil up, but sometimes that's hard for people to see, like the steeper the line is. So maybe think about the y-axis, like it maybe it's helpful to go to the y-intercept and look at the y-axis. So it's here and here. You want the y-axis part that's above the line, so like where the numbers are bigger. So I want to include this part of the y-axis in my shading. So therefore, I'm going to shade this whole side of the line over here. And I'll give you a helpful way to test the shading if you're unsure which way is above and which way is below. Okay, now what I've done here is, again, I've given someone a visual for where all of the solutions to this inequality lie. Okay, so I don't know if you remember back here when we did on the number line, the open circle meant that 4 was not an answer. That's why we didn't shade it in, because 4 is not greater than 4. So it's the same concept down here. If we do a dashed line, that means the ordered pairs on the line are not solutions. Like I'm not coloring them in, those don't work. Since this one's a solid line, the ordered pairs on the line do work. And where I did my shading, any of these ordered pairs make this inequality true. So let's just test it. I could do any ordered pair in here. Let's maybe do this one. It's -2, 2. You probably can't read that, but that's -2, 2. For my x and y. So let's just test it. Like if I plugged in 2 for y and -2 for x, let's just make sure it does work. That'd be -6 minus 1, which is -7. And yeah, 2 is greater than or equal to -7. So it worked. Notice that the difference between an inequality and an inequality has so many more answers. The equation, it's just the points on the line. But this inequality, it's all the points on the line and everything shaded above. So it just like makes the solution set so much greater. Okay, we're gonna practice a few. So first one, and if you need to flip back for your steps, do it. Want to be an mx plus b, this one is. So I'm going to go ahead and plot the points like normal. Y-intercept is 3, slope is 2 over 1, so I go up to right 1, I could go down to left 1, plotting the points, nothing's changed. But now I have to think about my two new things here. So the first thing is, what kind of line is it, dashed or solid? This one does not have the solid line underneath this sign, so this is a dashed line. So this is how you draw it. Something like that. That means the points on the line don't work. They're not solutions. Okay, now I have to figure out, do I shade over here or over here? Which side of the line do I shade? Well, we said it's either kind of above or below. What's this one? This is a less than, so I should shade below the line. So again, maybe think about the y-axis specifically. Go to the y-intercept. You want the y-axis below the line. So that's down here. So I'd shade all this. If you have a hard time telling like above and below, you can test a point. Because guys, where you shade, that's where the solutions lie. So if you're not sure, and I'm going to show you an example of 3, you're going to test a point, and if the point works, then that side of the line is where the solutions are. But notice the directions here, and we need to kind of add a word. They say graph the inequality, then we're going to say name an example of a solution. So they want me to give them an example of a solution on this. So I cannot pick points on the line because it's a dashed line. So I've got to pick any ordered pair within the shaded region, and I don't even have to test it. I'm pretty confident here. So I don't know. Let's just do like this one right here. That's 3, 3. You could test it to make sure. Let's do that just for fun. Plug in 3 for x, 3 for y. Let's see, 6 plus 3, that's 9. 3 is smaller than 9, so it did work. Okay, tons of answers that you could list here, anything in the shaded region. All right, example 2. Step 1's a problem. This is not an mx plus b, so I need to solve this for y. So I'm going to subtract the 3x. And then divide by -5. And hopefully a little red flag will go off in your mind. I feel like a lot of us would forget this, but make sure you make a note here. If you recall from Unit 3, when you're moving stuff around in an inequality, you have to flip the sign when you multiply or divide by a negative number. So I divided everything by -5. I need to flip the sign. And I'm making this note here. Flip the sign when you multiply or divide by a negative. You're going to see that a lot on these problems, so be careful. So if I write what this looks like, it'd be y is greater than or equal to -3 over -5 would be positive 3/5 x. 10 divided by -5 is -2. So this is what I want to graph. You plot the points like normal. This would be a solid line because it has the solid line underneath the sign. That means any ordered pair on the line is going to be a solution. This is a greater than, so I want to shade above the line. And above is a little bit easier to see on this example. And any solution in the shaded region, any ordered pair in there, would work as an answer. Or I could even pick points on the line, so that's what I'm going to do this time. Let's just do this one right here. That would work because it's on a solid line, so that's the ordered pair 5, 1. All right, example 3, and I'll tell you right now, you guys, I want you to try example 4. I'm going to end with example 3, though. This would throw people off because there is no y. So it's not really in mx plus b. Remember, if there's just an x or just a y, it's either vertical or horizontal. Now, the most common way people remember, and I've said this so many times, but this is the x-axis. So an x line is the opposite of that, and it's actually vertical. So I just have to find 5 on the x-axis, which is right here, and it's a vertical line through that point. Before I jump to draw the line it is an inequality, so I need to think about what kind of line is it, dashed or solid. I don't see the solid line underneath the sign, therefore this one has to be dashed. Okay, I told you guys that you either shade above or below the line, but this one is an exception. There is no above or below the line. You either shade to the left of the line or to the right of the line, not above or below. So if you cannot tell which way to shade, and this goes for any problem, you can test a point. And I'm going to tell you to test 0, 0. You can test 0, 0 to figure out your shading. Here's what I mean by that. Here's 0, 0. I know I shade where the answers are. So if 0, 0 makes my inequality true, then I want to shade over it. Well, yeah, there's two numbers, 0 for x and y, but this only has x's. So I can only plug in 0 for x. So plug it in and then take a step back and think if that's true. The mouth should open towards what's bigger. So is 0 bigger than 5? No, it's not. So if 0, 0 doesn't work, you don't want to shade that side of the line. I want to shade away from 0, 0, which would be over here. So any ordered pair in this region would work. Let's just do like 6, 1 maybe. That would work. Okay, try example 4.